So yeah. So here is so what we did on a day one. Any of you able to remember what we have talked on the day one?
I think you talked about different architecture within the data processing layer, how
Uh,
each component fits in where, what kind of data processing, like a
yeah,
stream.
right. So primarily, let me do just a small recap, right? So this way we all have. So on a day one, we have started like how AWS Analytics is divided, right? So we have talked around a few, like four different or five different pillars. One of them was streaming. Any of you able to remember like couple of services which I talked on the streaming or put on the streaming? One was the Genesis.
Genesis,
Yeah. Other one was Kafka.
Kafka.
So then we have various different variants on Kinesis and Kafka. What other pillars I have talked on the analytics? Streaming was one.
You talked about
Analytics.
big data, advanced analytics, and machine learning.
Big data was one. Good. So what all services were there in a big data?
Does Athena fit here? Data Lake or Athena?
Yeah, Athena is there. EMR was there. Glue,
Redshift.
Redshift. Let me see if something else requested to join according. What else? This is the one. This is the second. What was the other one?
I think one of them was search.
Search. Very good. Was the service was there in search?
I think Elasticsearch you talked about.
Mm-hmm. Elasticsearch, Open Search, right? And once done, like we had this fourth pillar, right, which is the BI one,
Yeah.
and then we had this fifth one, which is advanced analytics. I talked around like your ML, AI, or in fact, and now we have this Gen AI stuff, right? All those things comes into the advanced analytics. So once we have talked around this one, then we have talked around the concepts of big data. Right. Do you any of you remember like what we call as a big data? Once done, like we after the big data concept for big data, we have talked around briefly talked around what is data lake, and then we have talked around characteristics of data lake. So this is important. Can few of you able to list me the characteristics of data lake which we have discussed in our last meeting?
It can be structured or non-structured.
Okay, that was one. So structured, unstructured. So in a way, like you're able to store, and then I have also solved semi-structured. Right?
Semi-structured.
So in a way, you're able to store all the data in single place, right? So that is characteristic. So if I have some interviewer asking me, hey, can you help me to understand the big data, what the big data is all about, right? Then you will be giving the definition and then you will be talking about the characteristics of the big data, right? Data lake. What else? I listed a couple of them as well. Remember, very important. A couple of concepts was very important, which I have repeated again and again.
Read on schema.
Decoupling
Schema on
of
read. Decoupling.
storage.
Storage versus compute and compute.
Yep. See, if you are not able to remember all this concept, right, and as a beginner, then you won't able to make much of progress. So this is revise the chapters before coming here. So this way, it will be easy for you to understand if when I start moving from here. And as many of you have mentioned, like, okay, hey guys, I'm new on this analytics, and primary motive, almost like 80 or 90% people have responded. Primary motive is for me to upskill myself or find a job on the analytics, right? So in order for you to finding a job, you have to go for an interview, right? So in an interview, these are the questions being asked, and trust me, I do a lot of interviews as well, and that's what I try to understand. Like, okay, whether people have a basic understanding or they just start the bookish and knowledge, right? So decoupling of storage and compute. What does it mean? Okay. What next? What was the next? Someone was mentioning the schema on read. Right? And one more other thing is, which is more like someone also mentioned, it allow you to keep the data for a longer period of time for future use cases, right? So these are the things which you can think of. Hey, the data lake offer me also like auditing and all other things which is being there, but these are the primary, or if I have to just, these are the three main pillars or four main pillars. Well, possible to, yeah, sure. Let me share. Where is the chat? Okay. Now we are moving towards day 2, right? And this is where it gets interesting. So usually, and this is where we're going to learn about different interesting concepts when you build the data lake, right? So usually when you architect the data lake, or let's say if I have to have uh, when we think of architecting the data lake, So couple of things is being evolved, right? Or let's say, so first thing, what do you think? Like, what will be the first thing when you think of, like, architecting the data lake, right? Or when we think of an architecting the data lake is, then again I will be dividing into multiple pillars. Just keep remembering this one, because this going to be, we will be talking on this one entire, like, all those 12 days which we are looking to have our sessions, right? So one is data source, right? Other one is, once we have identified the data source, other one is going to be ingestion. Third one is going to be your storage. Mhm. And thereafter we're going to have a transform, and at the end we're going to have a consumption. Okay, so data sources can be a number of data sources. One will be, the most common will be your file. When I say files, it will be the CSV, Avro, Parquet, etc. All these are the file format, right? But think of, like, you will be generating the files, XML file, you will be generating JSON file, all the applications will be generating files. It can be a system log file, it can be an application log file, it can be any other file which is being shared by the vendors, right? So the idea is like the files. Other data sources will be your relational data database. Do you guys remember any relational database? Can you guys name a few?
Oracle,
Oracle, yeah,
Microsoft SQL Server.
MS SQL,
Postgres.
MySQL, yeah, Postgres. So all these are their relational databases, right? Let me go to the next page, and then we talk about the data sources as well. What other data source you can think of, right? We talked around the file, we talked around the relational data store. I can think,
NoSQL databases.
yeah, non-relational databases, like, okay, or NoSQL. So NoSQL, do you know any name of the NoSQL?
Dynamo,
Dynamo.
DB, and the Marco.
I see someone just joined. Right. Okay. Dynamo, what else? Mongo?
MongoDB. Yeah.
Perfect. Great. And non-relational database, what else? Think of data can be a data source. Streaming data sources, right? So any streaming name of streaming data sources?
Does the Kafka fit in here, or
Just give me the data source name.
like a queues you're talking about, or?
So just think that what all thing you're able to stream, right? So if you go to any website, you do a clicks, right? So we're going to be a click stream. Usually your applications, your systems generated logs, right?
Mm-hmm.
Some logs.
Like,
Your-
are you talking about the like a small log or?
any kind of log, right? Application log, your system
Oh,
generate, your application generate logs, right? Application logs. Then you can have a video, right? You can have an any other streaming like transactions. So like you can do a CTC, right? So you will be continually like here you can put CTC, which is change data capture, which is mean continuous ingestion of your data, right? Or generate, or you can think of creation of your data. So why it is important to understand when we talk about, hey, what kind of a data source which we have, and based on the data source, how you're looking to have your ingestion, right? So based on the data source, remember we talked around all number of different services here initially when talked around uh, uh, here, like, okay, streaming, big data, search, etc., etc. So all those services which we have talked here, which going to fit into in here in different layers. So when we talk about, hey, how I'm able to ingest the file, right? So AWS allow you to have a different ways to move your file from your on-premises uh, to Amazon S3, right? Or from your laptop to Amazon S3 or anywhere else, right? So there are a number of ways you can able to move the file. There are entire Snow family is being there, like where we can have a uh, 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 snow devices, right? Where AWS send you those devices at your data center to load the data and move the data to S3. But those are the more on the big data side, or like if you have a lot of data being looking to move. Apart from that, you're able to use AWS Data Sync, right? So if I have to move the files from my from my data center or from my local computer or local server to AWS, right? I can think of using the AWS Data Sync, right? Or if or I can use Lambda. Don't worry about like all this service for now, but Lambda is just think of a compute being provided by AWS, so you can write your piece of code. So I will be writing Python code here, or Scala, or whatever, or Java, or any code, and I will be going and editing this FTP location, right, where I have my file stored, and then reading the file and storing the file into S3. Apart from that, you're able to use AWS Glue, right, to bring the data from a number of files. And again, right, in AWS Glue as well, it has a various different engines like Python, Scala, or PySpark, which let you to read the file and put the data into your storage layer. So when we talk about files, there are systems that do that. Uh, when we talk about relational databases, right, AWS has something called uh, data migration service, call it a DMS, right? So this stands for data migration service, which will let you read the data from your relational database and have the data being stored into different kind of storage. We will be talking on the different kind of storage as well. And then also it let you connect to the other, all kind of relational databases.
Hey, Naveen.
Mhm.
When we're talking about ingestion, like transferring the data from the data center to AWS,
Mhm.
where does Snowmobile or the Snow Cone and all those devices all fit in?
Yeah, I said like that's a more kind of a Snow families devices, right? That is more like, hey, I have lot of data sitting. Let's say you are doing. I can give you a real world example. You will be doing your Hadoop migration from your from your on premises and we'll be looking to migrate petabyte of data, right? So if you have to move the petabyte of data, let's say you have AWS Connect, which will be connecting your data center to your to cloud. But when you move through that, it will be super. I mean, it's not going to be super fast because it has a right. So and then other traffic also going through that bandwidth. So that's where you will be sending those physical devices we just talked through, like snowmobile, snow cone, and all those things. Like I don't know, I don't remember all the names, but all those snow families devices being sent over as a physical device to your data center, right? And that's where you will be copying the data and moving the data to Amazon S3. So literally, you just it's going to be a suitcase type, or it's going to be a big truck or etc., which can be hooking to your data center, copying all the data, and then you will be shipping back to AWS. AWS engineers going into their data center and putting the data into storage like S3. So that is more on the where you have to have a lot of data. I believe that Snow uh, that let you copy like 50 terabyte from 50 terabyte to somewhere. I don't know. I don't remember the. I'm not able to recollect the range, but again, it is the higher side of the data, right? So if it's in multi-tab.
So shouldn't we list that also in the ingestion pillar?
Yeah, I said like that is there, but we are not covering the Snow family
Okay.
here. That's the reason I have included. But you can think of Snow can also be a Snow family, or Snow devices can also be part of your ingestion when we say, hey, you're looking to bring that lot of data from your on-premises there. But that we are not looking to. Usually we are not, as because when we talk about analytics, we're talking about the data pipeline, right? So it's more like a continuous flow of your data, or that is more kind of a one time of a data copy. I have the data here. We are talking more on the data pipeline. That's the reason, like when I say like architecting the data lake, that's the reason I said like, okay, Snow family we are not including because that is more on the one time of a data load.
Okay.
Yeah. Makes
Thanks,
sense.
Navin.
Yeah. So that we have relational databases, and thereafter we're going to have a non-relational databases, right? So for the non-relational databases, you have to have bring the data from from different non-relational databases. So AWS Glue allow you to bring the data from the non-relational databases. You have a Kafka. You have a Kinesis, etc. And then you have I believe the DMS also let you bring the data from the non-relational data stores, right? So DMS is, again, I said like data migration service, which let you to connect to your data source and have the data being ingested to your different data stores. Streaming, this is where your services like Kafka, Kinesis, or you have your Spark streaming. All these services come into play, right? So this is your ingestion, which let you bring the data from your different streaming services and have the data being stored. So now we have understanding how that is, and again, right, the DMS can fit here as well, because if you have a CTC data, it will let you read the data in a real time and have the data being stored. Here, when we talk about DMS, or when Kafka and Kinesis would say, like, you can think of DynamoDB stream. It'll let you read the stream and bring the let you store the data in a real time. Glue has a connect for multiple databases like DynamoDB, MongoDB, etc., which let you connect and bring the data into your database, and then again the DMS also. So these are the ways, like these are the services which allow you to do an ingestion. Now we talked about the storage. right? So what all thing or what all storage you can think of, like when you're storing your data in your in your AWS?
Like S3?
Amazon S3, that's going to be our data lake, right? We have a Redshift, which can be your data warehouse. We have all kind of relational data stores, right? Which is think of your Aurora, or Scala, and after Aurora, and you have RDS MySQL or RDS. Just think of an RDS, all kind of an RDS. It's a MySQL, Postgres, etc., etc. Right, and then you have your non-relational data stuff. We already have listed all the name of non-relational data stores, right? So you will be bringing the data from one data source and having the data being stored into another data sources, right? Our course will be primarily talking around this, like data lake and data warehouse. But you have also have an option to think of, like, okay, there are maybe need of you will be storing the data in a relational data store for your purposes. But in this session, we will be primarily concentrating on this two one, because this is related to analytics, and that can be also be used in analytics, but this is more primarily on the application side, right? Not on the analytics side, most probably. So we will be concentrating on the data lake and the data warehouse. Once done, now we are looking to consume the data. Okay. Oh, sorry. Before that, we are looking to make a transformation. So what are some transformation services, or you can think like what are transformation we usually do when we bring the data from one source to another source? Any idea? Have you heard of it? Like what are transformation you do that? So you must be cleaning your file, right? Cleaning and cleansing of your file. Which comes like checking the null value. If the file has a null value, dropping it. File has an unwanted value, like unwanted columns and everything as such, and then you have any garbage value in it, etc. All those things you do and see before making or putting into different layer. You will be kind of making a transformation against your data set to ensure the data has a quality. In a relational database, you're looking to see, maybe doing some kind of aggregation against your data set, some kind of a filtering against your data set, right? Or some kind of you can think of applying any business logic. So all those things you do in a transformations, right? So remember I talked around all kind of services. Do you guys able to remember any transformation services?
Glue.
Right. So one is your glue. What else? EMR, which is Elastic MapReduce. You can think of a Lambda as well. A lot of people use Lambda, but Lambda usually do not come under the analytics service. It goes into the compute service. But again, think of like making there's a lot of other services like being used AWS batch that is being used as well for making some kind of a transformation. Around analytics, primarily we have Glue, EMR, KDA, the Kinesis Data Analytics, right? So that is allow you to do transformation as well. We have Kinesis Firehose. And then we have a DMS as well. DMS also let you make some transformation against your data. And again, we also in some use cases we will be also using Athena. Athena also let you make a transformation against your data. So all those services which let you make a transformation, right? Once you're done, once you're done making the transformation, now you will be going and consuming the data, right? So there are n number of ways for you to consume the data, right? One way is for you to reporting. What all data you have there being transformed, now you're looking to consume data as a part of report. So what all services are there to me to consume the data as a reporting within AWS? QuickSight, right? So you're able to use QuickSight to consume the data. You can able to create a report. Other one is you can think of open search dashboard or Amazon Open Search dashboard. Okay. It create a dashboard for you to consume. Other way, this is more around the reporting side, right? Now I wanted to have my data being stored and I wanted to do a query or SQL query against the data. Or ad hoc reporting, or I want to do it. So what all services are there in for me to consume the data through the SQL query?
Athena.
Athena comes first in a name. Yeah. Any other service let you query the data as in through SQL? What about Redshift? Right? And all other databases. So these are the databases let you do it data in. Someone has asked question. Okay. So there are like now you have a reporting service which let you consume the data. Now you have a SQL query which let you do a data to query, right? What else you can think of, like way for you to consume the data? Maybe you will be feeding to an application, right? So you're making an like a consumption here. Sorry. I can move this thing. Okay. So we have this consumption through API, right? So there are many APIs, like you can do it data API through on a Redshift, but the idea is you will be consuming through the API, right? You will be making an API call and able to consume the data. And data can be stored in anywhere on your databases, on your data lake, or you're able to make the API call and able to consume the data. Other way of you to consuming data is now it's getting very popular is through the notebook. Okay. Sorry, should be calling it Jupyter Notebook. programmatically you will be data. So what all services has a notebook in it? One is your Glue has a notebook, EMR has a notebook, SageMaker, and then you have your Athena also has a notebook. So there are a number of services within AWS which allow you to consume the data from the notebook. And right, so this is how this is not entire list, or there may be another way, other ways for you to consume the data as well, if I remember anything in down. But primarily more around, like when we talk about the consumption on the analytics side, we will be talking about reporting, we will be talking about SQL query, and then we will be talking about near real-time congestion. Hey, when I'm building the fraud detection pipeline, right? How the data being consumed in near real time. That is there by different services. So this is how it is there. Now what we're looking to do is any questions before we can move to the next, because now we will be going and designing our very first pipeline to understand, and then I will be asking you to help me to design this. I will be giving you one assignment for like literally for 5 minutes, and then each of you have to present like how how that is being get designed, and then I will be providing my solution. Okay, so any questions here so far?
One basic question, I don't know, but I always get confused between data lake and a data warehouse. You could elaborate on that.
Fair enough. I will that. Any other question? So this is your data lake, and this is your data warehouse. So remember, we have talked around a couple of important things on a data lake. It allows you to store. I'm wondering if you guys getting some background noise. Like my family is talking, you guys are hearing all those things, or it's like not much of noise.
I'm not hearing anything.
Yeah. So
Okay,
so
perfect.
on that side.
Perfect. Yeah. So, or else I could have put a headphone. So if it's not disturbed, hope it's not disturbing you. All right. So remember, we talked around on the data lake side. We said like, hey, it allow you to store all kind of a file, right? You're able to store relational. You're able to store your flat file, right, or your structure file, unstructured file. I'm not writing it down because I have wrote it a number of times. Your semi-structured type, and any, like, you can think of when we talk about here, unstructured is your video, audio, semi-structured is your JSON, XML, all kind of a log file. Structure is your CSV, right? And then here's the Parquet, etc. CSV, TSV, and all other files, right? Do you think like data warehouse able to store all kind of a data?
No.
I'm sorry. So for the data warehouse, you have your data should be in a fixed structure. Okay. So primarily, only the structured data is being stored in a data warehouse. Okay.
Okay.
So this is one difference between the data lake and data warehouse, where in a data lake you can able to store all kind of a data, whereas in data warehouse you're able to store structured data. Now some data warehouses is allowing you to store JSON, etc. Right? So they have a data type like JSON data type where you're able to store JSON data, but that is very limited for one or couple of data files. But in general, if someone asks you like, hey, what's the difference between the data lake and data warehouse? Data lake let you allow to store all kind of a data, whereas data warehouse only allow you to store certain type of structured data. Okay. Other very important concept we have discussed around data lake is decoupling of storage and compute. Right. So in a real sense, you can able to decouple the storage and compute. Right. You can have a you can have a as much as storage or as much as data being stored, and then you can have as less as compute being used. Earlier, nowadays, now the like new data warehouse like Snowflake, Redshift allow you to do that as well. Decoupling of storage and compute. You can have that as much as data being stored in your data node, and then you will be using, or as much as data being stored and in on this all this data warehouse, and you can use as less as compute to do a computation against the data. But in a true sense, like data lakes support these characteristics. uh, this data warehouse also allow you to do that, but this concept is came from the data lake earlier. Like, okay, if when we used to talk around the Teradata kind of a data lake, when we used to talk around Oracle, MySQL, etc., that was not the case. If you're increasing the data, you will have to increase your compute power as well. So one is like, hey, it also data lake. This concept came from the data lake, and now this data warehouse also is following it. Make sense? Other other important concept we have talked around here is schema on read. So when we talk around schema on read, what it will happen is, as we have not defined sometimes it's getting lag. So no upfront schema, right? Because you have not to worry about hey, how my data is going to look like when I'm building my ingestion pipeline. So this way the ingestion will be very fast, because you have not to worry about uh, you know uh, like how the structure look like of my data. Whereas in a data warehouse, you have schema on write. So just think of, like, if you have to ingest any data in a data warehouse, you have to create your table first, right? You have to have a database, and you have to have your table. So this way, you have to know the structure upfront, even before doing any ingestion of your data, right? And if your file or anything else look like which is not matching the structure or definition of your table, then you have to make transformation just to ensure that is being done. So what will happen is that make ingestion slow. Here, ingestion is fast because I have not to have any upfront schema being designed. Okay. Other thing is, make sense. Other other thing is data stored in in open source file format. It means you will bring the data as a CSV. You're able to read data as a CSV. You bring the data as a Parquet. You're able to read the data as a Parquet. You will be bringing the data as an ORC. You will be able to read the data as an ORC, XML, JSON, etc. Right? So any format you're bringing the data, your data will remain in the same format, and you will be using the data. Whereas here, the data gets stored in proprietary format. So if Snowflake has its own format to store the data, Redshift has its own, Teradata has its own, right? All these databases let you store the data, but you're not able to access data as a file. Like, okay, for instance, if you're storing the data in a data lake, let's say Amazon S3, you will be going and reading the file as a CSV. Whereas if you're storing the same CSV file into your data warehouse, that we're going to do, and we're going to learn in during our Redshift session, how you're able to do that. But that become the Redshift table, right? You're not able to able to read the data. Other important concept which we have talked around is when we say decoupling the storage and compute, is like your data will be stored. So if you're dropping the data will still will remain in S3, but whereas when you drop your data here, you will be losing your data, right? So sorry, that concept comes in the schema on a read. So if you're dropping the data, still will be is more think of an external table. It will be you will be creating an external table on your data lake, and here you will be creating an internal table, right? Apart from that, this is there. One very important, this will be like, if you are going on interview, this, if you don't forget to mention this points as well. This way it will be all those things I had just talked around is primarily more around user think of like being bookish, right? But here is the other couple of characteristics. Usually when we talk around like any systems, this comes down to 3 points. One is your concurrency, right? Other one is your latency, and then third one is your data scan, right? So when we talk about data warehouse and the data lake, right? So data lake has a higher concurrency. Can anyone define like what the concurrency is? Any guess?
Sure. Be like a process reading the same data at the same time, right? Concurrent read or concurrent write.
Exactly. Yep. So it has a higher concurrency. You can have like a lot of user reading the data or writing the data in your data lake, right, at the same point of time. Whereas data warehouse has a limited concurrency. Latency.
So can we go back on concurrency? That means it potentially it could have a conflicted record in data lake. Is it right?
No, it means
So you
like
could have a parallel writes. So that means you could overwrite somebody else's data that could be a stale data, right? You are there should be a trade-off, right? If you are doing a high concurrency system, which basically data lake doesn't have any locks, right? That means
all right.
data warehouse may be having some locks. That's how it manages the concurrency parallel writes, right? That means potentially you could have a conflicts, right?
Usually we're talking on side of the world, right? How high concurrency read. On the right side of the world is more like, because the data lake, when we talk about if there are any conflict, how the conflict is going to happen, any bad data, all those things, then we are going much more granular. Okay, how the system is being designed. Here
Okay.
primarily more around talking the read concurrency. But what you're talking is more around the databases are the data warehouse are designed. They follow the ACID compliance, right?
Mhm.
So
Okay.
they will ensure, okay, if there are conflict, how that's being resolved. Whereas data warehouse, there is data lake, there is no such concept, right? Now we have transactional data lakes that I can talk down the line. Uh, I am getting this noise, so if you're not speaking, just put yourself on mute. So this one is you know, but here primarily more around we're talking on the how concurrently how parallel we able to perform. Okay.
Okay, got it. Okay. Oh, okay. Maybe my point of view may be a little different. The reason maybe I was thinking more of a transactional processing system. In this case, it's more of analytical processing system, right? The data won't change that much.
Right, right. Again, right, as I mentioned earlier, that is more on the asset side of the world, right? So
Yeah.
where you can think of relational data store, relational databases like your Aurora MySQL, Aurora Pool.
Yeah. Mhm.
Those are being designed for those specifically, whereas data warehouse is more on the read side of the world.
Yeah.
Right, with the batch, if you're not like having thousands and thousands transactions happening on a database from the.
Yeah. Yeah, I got it.
So then other is your latency. Uh, latency. Anyone explain what the latency is?
And how much time does it take to get the data or read the data?
Yes, and so it has a high latency. When I say high latency, it means it takes some time to bring the data from your data lake. When I do a query against the data lake, the response time is slower as compared to here. So I have low latency. Low. Here I have high latency, right? And then it comes down to data scan. How much data I'm scanning allow me to scan, right? So as I said, like, you can store as many as data in your data lake as, right? Whereas data warehouse has a limitation is you can literally expand it, but right? In a theory, the data lake allow you to have much more data being stored. Not in theory, even in practical as well. So when you do it, like, if you're able to do a high data scan when against the query, let's say I'm putting a query, I want to read my entire data set, which goes in the petabyte. Data lake allow you to do that. For the data warehouse, you will be running into challenges or any other thing, right? So in a way, it has a high data scan as compared to it has a low data scan. Or when you will be choosing the data warehouse, when you do not want it to read petabyte of data in a way, right? That's where all the time. That's where the difference come into picture. So are we clear now? What's the difference between the data lake and the data warehouse? Any further confusion?
Thanks, Naveen.
Okay. So now it's time for you guys to to do a small session, a small you know assignment, or I don't know, maybe, yeah, assignment is the right word to use. So assignment is, I have a requirement. So someone came to me and said, hey, I wanted to do a query against bunch of CSV files. And these are the sales or employee files. So I wanted to do a SQL query right? Or just think of, right? Maybe I just give you some hint, but I wanted to do a query, and this is my file format. Okay. Now help me to understand here. First, help me to build this pipeline, right? Uh, how what you think, like, okay, how the data is being, how you will be reading the data, how you will be performing the ingestion. First, list me the data source first, and then tell me the ingestion. Then tell me where the data is being stored, and then eventually tell me where the data, how you're looking to process or consume the data. Okay, so I will give. We are at 10:02. We can start at 10:05, and then I will be coming each of you and asking what you have built. Okay, so all you have a 3 minutes to.
So a quick question on this one, right?
Mhm.
So is the CSV files are pretty much when I say static, you have only bunch of files, or there could be files keep coming up.
Just think of static file as of now for this use case.
Okay, that's a static.
I have 5 CSV file stored somewhere, and I have 5 CSV files stored in my FTP, right? And then I wanted to have the data being ingested. I wanted to have data being stored because this is my data source. I wanted to have data being, because we are not making any transformation. It's a simple, so no transformation. And then I'm looking to use my data as a query. Now help me to understand what all services is going to be there, and I will let you guys think through for 5 minutes. I will, maybe I can go back and put this here, this sheet for you to understand. Uh, right, okay, how that is being done. Yeah. Let me go back here and see who all are there. Okay. Okay, let's get started. So what do you think, like, okay, how I should be ingesting the data if the data is in CSV format? I forgot to mention in earlier, right? There are a couple other ingestion as well. Way, like, uh, you can use CLI as well. You can use Boto as well. So Boto that can be used in your Lambda, etc. But Boto is you think of a in a Python way you to interact with AWS. So, anyways, just help me, give me, based on the services which we have or learn in our session, how you think, like, okay, I should be reading the CSV file.
I think we can either use the Lambda to read the file,
Mm-hmm.
or probably we can use the AWS Glue to read the file, CSV file.
Mm-hmm.
Lambda mean probably you'll be writing some program in some JavaScript or a Java,
Mm-hmm.
take the data and then read it, and then we can push it to some storage. Like in this case, maybe we could put it in Redshift, right?
Why doesn't just why you think we should be putting it in a Redshift?
Or we can put it in RDS because it's only small file, right? Or if we feel like since it's a static, we are not going to change, right? So in that case, we can put this data in. I'm just throwing, right? Maybe my understanding is not a whole lot. So I could take this files, put it in S3 bucket, and use Athena to read that data, right, on the fly. Do I need to write a program to ingest the data somewhere, or I don't know? Maybe the underlying the architecture uses Glue to read the data. I'm not sure.
Okay. And for the query, like, so as we have already, I think, realized we already passed the 10 hour, 1 hours. But so let me help you to understand this one, okay? And then in next session, we can talk on this one. So here the simple question was, the simple ask was, hey, I have this bunch of file and I wanted to do a query against it, right? So again, right, if someone asks me this question, you have to do some proving as well, okay? The first question was asked like, okay, this a continuous file or this is just a static few files, right? Like how the data is being arriving. That is a good question. So that is there. Like, okay, these are the bunch of files. I should be asking, right, size of the file. What if I have this 5 files in petabyte? What if, or if the same file is in megabyte? Does it make any difference the way I choose my solution? It does, right? So if I have the file in petabytes or in terabytes, like multi-terabytes, then I won't able to use any of my ingestion services which is being listed there. Then I have to think like, sending those snowmobile or snow boxes to the customer end to bring the data in, right? But whereas in our analytics use cases, the file is usually in GBs or sometime in terabytes or in MBs, right? So that is an important question as well for you to ask. Knowing like, okay, what's the file size, right? So that you will be doing a proving. Other things you will be doing is when you say like, hey, I wanted to do a query. What do you mean by query? Are you looking to do a SQL query? That is what you usually use, or you're making to use an API call, or how, like, or any other kind of a query, or you're looking to do using the visualization tool, right? Or the BI reporting queries, or etc. That also change, like, okay, how am you looking to use my, what will be my consumption layer, what the tool will be happening. And then I will be asking how many queries you are looking to do per second, right? And thereafter, like, what will be the latency requirement? But again, these are the very advanced. And for this use case, the ask was very simple, but I will just put like a couple of points. So this will be, I have this CSV file. I will be using, let's say, AWS Glue. I assume my file are small. AWS Glue. I have the data being stored in S3. And and I will be putting into using Athena. This is primarily more around a analytics pipeline. This can be here. It can be a Lambda too, if the file is really small and able to load under the 15 minutes, right? So, but as Lambda is not a part of analytics services, we will be removing this here. We are just concentrating on the analytics service. So if I have to build a pipeline where I will be reading the data, I will be using this CSV, having the data as a part of Glue, and then storing in S3 and putting it to Athena. And this is the simplified file, a simple way of you to have the data being brought in and have the data being stored. In next session, I will be talking how you able to read the data, how we able to have a CSV file being stored in S3, and then you will be using Athena to query the data. We will be just manually uploading the file, so we are not bringing this component of the file, but just simply I have one CSV file being uploaded to S3, and then we will be using Athena to query the data. So what I will be expecting from you to is revise all the concept which we have learned today, understood it, and ask me if you have. So you have not to wait for this session for asking these questions. You can put me on a chat, send me an DM, or just send me an email, whatever way you feel comfortable. I try to answer those questions, right? So in next session, what we're looking to do is I will request you to read about what is Athena. Anyways, I will be covering that one. But if you can go and just learn basics about it, that would be nice too. Yeah, I think that's what. So in next session, we're going to learn about Athena. So any questions or confusions which you had, right, which I can answer before we can close our session for today.
Yeah, I mean, it's a really good session. I know the problem looked very simple, but you brought in the complexity of it could get complex, right? Like, without asking any questions. That's really good problem to solve. Yeah, I liked it.
Okay. Usually when you go for an interview, right, if I'm an interviewer, I will be asking, hey, I have this CSV file. I'm looking to do a query against the file. Can you help me to build a pipeline? And if you're just going and saying, hey, just have the data being brought into S3 and being stored into query using the data lake, right? Or using Athena, then it's more like you're not doing a probing against.
Probing, yeah.
You're not doing a requirement gathering. Say, what's the file sizes, what's the latency requirement, how much query I'm looking to do, because that eventually changes the entire solution itself. But that is more on the solution architecting side. That's my job is. But here we are just going really small and very easy use cases and try to learn from them. So having said that, we are already 15 minutes past the session. So thanks everyone for taking your time and attending this session. If you have any feedback, do share with me, and I can try to accommodate in our upcoming sessions. Okay. So thank you everyone. Take care.
Thank you, David. Yeah.
Thanks.
Thank you.